In this problem, we have a 1000 par value bond that lasts for 18 years and it has a yield of 5%. And then at the 10th year, the amount of amortization of premium is equal to 20. So we want to find the book value of the bond at the end of year 10. And first of all, just note that there is no redemption value in this problem. And as before, as I've stated, if you're not given that, you can assume that the par value is also the redemption value. So this is redeemable at par. And this is a convention you also find in SOA exams. So in exams, I'm pretty sure they'll explicitly state that the redemption value is also equal to 1000, if that is the case. And this problem concerns ourselves with the amortization of premium. And if you're unfamiliar with this concept, you can check out the video on question 1. In that video, I explained at length what this concept is and how it works. So if you're unfamiliar with this, go check that out. So now I'm going to apply this concept directly. So first, let us come up with a formula to calculate the amortization of premium. So one thing you could do, of course, is to just check out this table and then use these formulas here. So this is the formula for amortization of premium. But then there's actually a really easy way you can reason your way to this formula. So first, we can just consider the price of the bond, so essentially the book value at time 0. And then we're going to use the premium discount formula. And you know that's equal to this. And I'm just going to write this out. And if we consider the book value at time 1, so it's not price anymore. If you consider the book value at time 1, it's essentially the same bond, but it's just that now it lasts for n-1 years. And if you write this out, you'll see that we get v plus v squared all the way to v to the power of n-1. So you see the difference between these two expressions is that this one is missing the v to the power of n. And the amortization of premium is defined as the difference between the book value. So the amortization of premium at time 1 is what is missing from this term compared to this one. It's missing v to the power of n. So the amortization premium is equal to c times g minus I times v to the power of n. And you can do the same thing for time 2. So for time 2, you can guess that it's going to be the n-1 term that's going to be missing. And so the amortization of premium at time 2 is equal to this expression. And then by the same logic, you can come up with a general formula. So Vn minus k plus 1. So if you substitute k equal to 1, you see that it checks. So this is how you get this formula. So you don't have to go through any special mathematics. All you have to do is just to apply the premium discount formula and just notice that this tiny bit changes after every year, so you get this formula. So you don't have to memorize any formulas. So now let's apply this formula. So in this problem, we're given that the amortization of premium at time 10 is equal to 20. And just now we found that c times g minus I v to the power of n minus k minus plus 1. So our n is equal to 18. Our k is 10, so plus 1. So in this problem, we're not given g, so that's why we need this formula to derive the value of this expression. But we're given we're given the yield rate, which is 5%, so we know what v is. So multiply this to the other side, we just get 1.05 to the power of 9. So now we want to find the book value at time 10. So all we have to do is just to apply the premium discount formula. And it's 18 years, we're at time 10, so there are 8 more payments in the future. So once again, this is at 5%. So now c is just 1000. And c times g minus I, we just found that that's equal to this expression. And then multiply this by 5%, and then plug it into your calculator. You'll find that the answer to this problem is given by 1200.5. So this is how you solve this problem.